Hello and welcome to this video. It's a pleasure for me to see you here, and you will join me today on two journeys. First of all, we will have a look here in this area because I'm searching for new places to watch for animals and take some pictures. And the other thing is that I want to explain a little bit what happened with the Log4j shell, what happened with the Solarwinds Hack, why this is affecting us, and what can we do to protect ourselves against all these cybersecurity reasons that are coming now against the supply chain. So if you're interested in this, then you are right here. By the way, my name is Sven Ruppert. I'm from Germany and developer advocate for JFrog, specialized on DevSecOps. And well, as you can see, I'm mostly out in the woods. Every 3 minutes I have time for this, and I'm using this one to record all my videos. So if you're interested in more outdoor style IT related videos, check out my YouTube channel. Have it in German, have it in English, and it would be a pleasure to see you as my new subscriber. And if you don't want to see anything about IT in the woods, then check out my bushcrafting channel. It's just relaxing stuff. Okay, so now enough. Let's start. Okay, what's happened in the near past? We had a disaster with Log4j, and it was from 0 to 10, value 10 CVSS score, but wasn't CVSS score. If something is really critical and they give CVSS 10, that means that the common vulnerability scoring system is at its maximum. So, but what isn't CVSS? Just in short words, CVSS is a common vulnerability scoring system, and the common vulnerability scoring system is something to describe in a very generic way how critical a vulnerability is. And it's based on different metrics. These different metrics are, can you just exploit the system over the network, or do you need physical access? Do you need the knowledge about a system user, or can you just exploit it in a way that's if you have just access over TCP/IP? Different metrics, so it depends on network statistics, operating system specifics, knowledge about the system, and so on and so on. So with this CVSS we have different versions. One version is CVSS 2 and 3 and 3.1, and the new one would be 4 someday, so they are just working on this one. CVSS itself is based on metrics, and the thing is that the score itself is a generic description, and this generic description must be mapped to your local environment. For this you have the environmental metrics to map this one to your own system. But if someone is talking about a value of 10, means it's the maximum, because CVSS values are in general between 0 and 10. 10 is the maximum. So based on all these metrics, you can calculate it. It's a little bit too much to explain it here in this talk, but if you want to know more about the CVSS values, go to my YouTube channel. I have a talk there about CVSS Explained, so I'm going through all these dedicated metrics and explain a little bit what it is. So, but having something with a value of 10 is really rare, and it's, I don't know how many vulnerabilities have they score already in the past, but it's a disaster. So the next question is why this is so critical. What's now the critical thing with this vulnerability? So we are talking about an open source library, and it's called Log4j. And Log4j is a logging library, and it's widely used since, I don't know, 10 years or longer in so many open source projects and products. Log4j itself is open source, so everybody has access to the source code, and it is surprisingly that since so long time this vulnerability is inside this Log4j API, but it's just found now and not years ago. So what happened with the vulnerability itself? So logging itself is just an easy thing. You are getting some strings and you're writing it some log files or some other part you want to have. This could be a queue for MQTT, it could be whatever. So you're pushing this message out. So you're logging it, you're grabbing strings, you're processing it a little bit, and then sending it to somewhere where you want to store it. It could be database, file system, whatever. So far so good, but there was this functionality that you had the possibility to go over JNI, this native interface, and to go here in a way that you can misuse the message that is pushed to this logging API. So normally you would say, okay, if I'm getting a string, I try to prevent myself against something like a SQL injection. So a SQL injection is a common vulnerability in a web interface where you have input fields, you are sneaking in with some SQL snippets and try to modify the action that will happening. The log4j shell is something similar. So you could send a string with an address, and this address will be used or interpreted to load something. So it's possible to load code from another place and start with execution itself. So you have different variations, so it's a little bit too much to explain everything here in this talk, but the log4j shell itself is now a disaster because it's widely used, it's nearly everywhere used in big environments like Amazon or Microsoft environments. It's inside products, in open source projects, and a bad thing is it's sometimes embedded inside this fat jars. So, and the worst part is like an repackaging. So you have this dependency to log4j, and then you're repackaging during the provisioning or during the creation of your own binary and sneaking with this code in. So there are several ways to get rid of it. So, but the main thing is it's widely used and it's very, very, very easy to misuse. And this happened just now. But how to get rid of this? To get rid of it, you have different possibilities. I don't want to say that this is a 100% correct answer, but you have the possibility to give some environment variables or variables that you are not using this functionality in a way that it can be misused, so that you're limiting the interpretation itself. Or in some environments, you're just removing the jar so that you don't have this functionality anymore. So, but why I'm talking about this? I'm talking about this because it's a vulnerability. It's hidden since a long, long time. It's used nearly everywhere in the world in open source projects, and it's just found and easy to exploit, and it has a CVSS value of 10. But this is a typical vulnerability in terms of I have a dependency and this is a bad dependency. But we had something in the near past as well that is a little bit more aggressive. It's not this traditional attack, it's an attack against the supply chain. Okay, a completely different attack compared to this log4j hack is more or less the Solarwinds hack. Solarwinds hack is a little bit longer ago, but it was an eye-opener for a lot of industries. So what happened? First of all, I want to explain a little bit what Solarwinds is. Solarwinds is a company that is creating a product called Orion Platform. And this Orion Platform is a software that is used to manage network infrastructure. You can imagine that if you're a customer of the Solarwinds company, so you're buying software to manage your infrastructure, it's not a small network what you're maintaining. So mostly it's a huge thing with hundreds, maybe thousands of items you want to control. And what do you need to manage network infrastructure is software that will run with very high rate because it will administrate the network. So that's more or less the Orion platform, but Solarwinds have, I think, around 300,000 customers worldwide. Imagine that every customer will have huge networks they are controlling and managing with the software. So we are talking about an enormous amount of servers that are managed directly or indirectly by the platform called Orion from Solarwinds. And so what happened here? What happened is that this hacker group, they didn't compromise, or they are not there to steal data. They didn't want to encrypt stuff to get money from them. They're not going to the customers because they have this software installed and there is a weak part of it. No, they broke into the company Solarwinds itself And then the target was a CI environment. So the CI environment was then compromised in a way that every binary that was created, so every new update, release, whatever, will be compromised in a way that additional binaries are melted in, so that after every CI run, the binary is compromised already. The next step is that Solarwinds will have this automatic update mechanism, because it's convenient and updates must be pushed as fast as possible to the customers. And exactly this was used here as a multiplicator. So Solarwinds got hacked, the binaries are compromised. Then with this automatic update mechanism, this compromised binaries was pushed to all of the customers. And in, I don't know, a few days, they infected more than 15 or 20,000 customers. Every customer, it's not only one server. We are not talking about 20,000 servers. We are talking about 20,000 networks. And this was a disaster, because this Solarwinds binary, or this hack, slept for 2 weeks, and then it starts reloading binaries from the internet. And this means that every infection by Solarwinds is a little bit different. So even if you're closing the main door, the main entry the Solarwinds hack opened, you don't know how many open windows you have. And this is really a disaster, because now we have so many different networks, we have so many different kinds of infections, and you can't trust the company you are getting the binary from. So all mechanisms like, oh, the company is providing binary, they're creating a fingerprint with MD5 or whatever, I'm checking this fingerprint is not working, because before this binary was produced, or this fingerprint was produced, the binary was already infected. So traditional and classical mechanisms are not preventing here, so you need something different. And now we have the challenge of attacks against the supply chain, against multipliers. And yeah, this is now a critical thing, because now we as a developer, we have to fight against two different sides. If you have something like this log4j stuff, it's a dependency we are grabbing from somewhere, and we have to make sure that these dependencies we are grabbing are not compromised. Okay. On the other side, with the Solarwinds hack, it showed us that we don't have to protect ourselves only against these dependencies we are consuming. We have to protect ourselves against that we are not the distributor of compromised binaries. So these are the two sides now. With attacks against the supply chain, we are not only infected by something that's coming in, we are infecting by ourselves. And this could be a disaster, not only from the vulnerability point of view, but from the economy point of view as well, because if you have done this once, it's most likely that the customer of you is not so, maybe will never trust you again. So, and this is a bad thing. So we have now these two sides, and how to start to protect against both sides now. So we heard about these different attacks, the log4j and the Solarwinds hack, and now the question how we can prepare ourselves, or how we can fight against vulnerability. So for this we have four main areas. They're called Zust, Dust, IST and RASP, and I will mention them briefly in a short overview, so that you have a feeling what areas for what, and we can start thinking about in which order we can start using them. So the first one is Zust, Static Application Security Testing, and what we are reaching here is a goal that we're analyzing the static context of an application. It could be the binary, it could be the configuration, it could be source code. So inside Zust we have different fields like component analyzers and the source code analyzer and all this stuff, but the main thing is that we need access to these components so that we can scan them. And if you're scanning binaries, we are scanning against non-vulnerabilities or binary patterns that are found somewhere earlier in some other malicious codes. And then we are analyzing the source code and try to understand the code, and with more or less pattern matching techniques based with KI, machine learning, whatever. We try to identify pieces of code that can be misused or can lead to a vulnerability later. So, but in the end, it's more or less the static application security testing, and you can start straight with the first line of code with this, because if you have something, then you can scan it already, because there's no need that it must be runnable or whatever. So static application security testing is the first one. The next one is exactly the opposite. It's DAST, Dynamic Application Security Testing, and this means that you have this hack approach. You're not analyzing all components that are part of this tech stack. You're analyzing it from outside. So you're looking at it like there is this wrap around. You have this API, the possibility to access it, and then you try to hack it. So this is mostly based on most common vulnerabilities. If you want to know a little bit more about most common vulnerabilities like SQL injection or heap dumps or something like this, then check out my YouTube channel. I have a talk exactly about the most common vulnerabilities in general. But here, DAST, the Dynamic Application Security Testing, is focusing on this hack approach. So I try to hack the system, and for this you need something that's running already. Then we can discuss about make it sense to run DAST techniques against the test system, because then it could be different from the point of configuration. So it may mostly make sense if you're focusing DAST on production systems, because then you have the full potential of DAST. So scanning for weak configurations, scanning for open ports, for example, and try to hack the system and try to misuse resources. So otherwise, make sure that your test environment is as near as possible from workload and all the other things to the production system, so that you have comparable results. But this is DAST, and this can be done just if something is already running. So you need something already running, then you can start with DAST. We had the static approach, we had the dynamic approach, and the next thing is that you're merging both together. This is an interactive application security testing, and it's more or less a combination of scanning all components, so static application security testing, and of the dynamic behavior of it. So we can think about interactive application security testing more or less like security debugging your application. The challenge here is that you need a lot of specific knowledge so that you can define your own attack vectors against the system, because this is the best approach for IS. So it means you interactively try to hack the system during the time it's running, and you're getting all the metrics out of it. So interactive application security testing is a combination between SAST and DAST, so static and dynamic, combined with the interactive part, so that you actively try to compromise the systems. We spoke about three parts of testing: the static, the dynamic, and the interactive one. And now we are reaching the point that we are protecting the runtime. So RASP is a runtime application security protection. So we are not testing anymore. Now we are protecting the system. So RASP approach is just usable on production systems, because with this you have this approach that you try to identify an ongoing cyber attack. This means that you have this agent approach mostly. So you have your production system, you have an agent that's running there and that's changing a little bit the bytecode itself. It's like performance monitoring, but in a way that you try to identify now with all these metrics in real time based on KI or machine learning or whatever your technique is behind. You try to identify an ongoing attack. So there is something that's going, it's misusing data, it's combining different use cases that are not good, and. So it's quite a complex topic, and it's a growing topic, definitely, for sure. It's very good to identify an ongoing unknown attack to prevent, and then you have two modes. One mode is just to monitor and alert, and the other mode is that you can just shut down the attacked system immediately. So RASP itself is a very good technology if you have all the previous steps done. So it's something that's protecting your active production system. Okay, after all this information about the four main areas of cybersecurity or protection mechanisms, the first question is, if I'm just new to this topic, should I focus on all of them or just on one, or what is the right order to start with? Let's start with RASP. Should I start with RASP? No, definitely not, because RASP is just the last wall of defense. It is protecting your system against ongoing attacks, but then you have an attack already, and it's good if you're preparing first against all the known vulnerabilities and all the weak points you have in your application. So RASP is definitely not what you should start with. RASP is a very good add-on if you have done previous things to harden your system already. So the first idea would be, if it is not RASP, then I could start with interactive application security testing because it's merging all the other approaches. Yes, for sure, but if you're new to this topic, it's most likely that you have no chance to really modify your own attack vectors against the system. So for this you need very high-skilled people in this area of cybersecurity, so to understand the tools, to use the tools in the right way. So make it sense to start with IAST? Definitely not, because this is just an evolution of the previous SAST and DUST approaches. Should I start with DUST? DUST is dynamic application security testing, means you need something that's already running, and it should be something that is as near as possible at production. So it makes no sense to start so late in your production pipeline with security testing, because then you have already done so many things, and if you find out that you have to change a library or you have to recode some stuff, then it's definitely too late. So DUST is definitely the second step you can start with, but definitely not the first part. After we excluded all the other three, there's only SAST available for the beginning. And yes, should I start with SAST in beginning? Definitely, because it's first of all the easiest approach, second it's the earliest approach, and third you have a lot of tools available that can help you immediately with starting with SAST. So you have different ways to start with SAST, but SAST is definitely the easiest and fastest way to start, and it's the earliest way to start. So this is definitely my recommendation if you're new to this topic, cybersecurity, focusing first on SAST approaches. I found a new spot for the next scenes, and I really love this environment. It's just unbelievable. It's nobody here. It's the forest is just growing in a way it wants, and nobody is just maintaining it or cutting trees or whatever. It's just growing. Perfect. I love this forest. But now, next step is, if I should start scanning, what should I start scanning? SAST is the thing you should focus on if you're starting with cybersecurity or cyber defense. And this means scanning of all components, but what makes sense to scan? So make it sense to scan your source code first. To say the truth, I wouldn't start scanning my own source code, because if you are looking at all this stuff, what you have, then the source code is first of all a tiny piece from the whole tech stack. And the other thing is the static analytics of the source code try to guess the semantic of the dynamic behavior. And to say the truth, the tools are more or less good, but they are not good enough right now. So they are still under development. And I would recommend not start scanning with the source code, your own source code. I would start scanning binaries. Okay, I mentioned it already, you should start scanning binaries, but why? So for this you have to check a little bit the proportions between all the pieces you're doing. So if you're writing your own code, even if you have a few 100,000 lines of code, compared to the dependencies you're adding to the project, mostly in the most projects, the lines of code you're adding as a dependency is way bigger than to what you are writing by yourself. Next step is, if you're going to the operating system, for example, you're using a Linux, the most likely is that you are just adding a few configurations, and the rest of the operating system is a binary. It's like a dependency, is something you are using, not producing by yourself. Same with Docker. If you're now running inside a virtualization environment, you're configuring it, and if you're looking at Docker, it even starts with a from statement. So it makes no sense to scan the stuff you wrote by yourself, but all the binaries that are included, and the same with Kubernetes. So if you're looking of the whole tech stack, then I really recommend start focusing on binaries, because this is the most dominant thing in the most environments I saw so far. So start scanning with the binaries, but what is a good tool, or what is a requirement for a good tool? What is a requirement for a good scanning tool? So I mentioned it more or less already. So if you're looking at one dedicated layer, we have just one thing that we are scanning, but vulnerabilities are in all layers, so in the application layer, in the operating system layer, in the virtualization layer, and so on and so on. So with every wrapper you're adding to your application or to your tech stack, you're adding more vulnerabilities, because there is no way to remove vulnerabilities with an additional layer. You can just add 0 vulnerabilities or more. So for this means, if you're focusing with a tool, with a binary scanner just on one layer, just for your application, let's say your Maven dependencies, and you are ignoring all the rest, then it's a bad choice, because a binary scanner must be able to understand the full impact graph, so all layers, the whole tech layer, and must be able to scan all tech layers so that you will have a full overview of all vulnerabilities and possible combinations in your whole tech stack, because this is what an attacker will see, more or less. If he's attacking the system, he's not attacking one single layer, he's attacking the whole system. And it means a good binary scanner must be able to understand all layers inside your application. So I mentioned that scanning binaries makes most sense because it's the most dominant part, but what's the right time to scan these binaries? First question is, make it sense to scan binaries in production? Well, if you're scanning binaries in production, you have an additional tool that will have access to production environment, and you should reduce the amount of applications that can modify or access production. The next thing is, scanning binaries from production makes definitely no sense, because the binaries are not produced in production. Binaries are produced pre-production. So it makes sense to scan not in production, because you're just using inside production all the components you have created before. So scanning in production makes no sense for binaries. Another part where you can scan binaries is pre-production. It makes sense to scan binaries before it's pushed to production, because then you can verify if everything's right and it's never reaching production, and you're limiting the tools that are accessing production. So it means scanning binaries before. And what's the right time to scan binaries? Well, immediately after they created. So it means, or if you are using them, so it depends. If you're creating your own binary, it makes sense to scan immediately after you created the binary itself. The next thing is, if you are creating a binary, so you are accessing binaries from outside, it makes sense to scan them before you're using. So long story short means, if you have dependencies, it makes sense to scan dependencies before it is part of your project. So it means you should start scanning binaries at a place where it's stored before you have access on it, more or less. So it means we have to think about what's the earliest way and what this term shift left means. But scanning binaries as early as possible, immediately after you created them or just before you're using them. Scanning as early as possible means that you should do it early inside production, and this term that is used around this one is called shift left. Shift left means that you are pushing as far as possible to the beginning of the production of your code, your environment, your application, and the earliest possible point would be for a developer straight inside the IDE. So yes, it makes sense to push every scans in the IDE, because if you're adding the first dependency in your project, it would make sense to see immediately inside your IDE if you have some vulnerabilities. If you have done this inside your IDE, the next step would be scanning inside the CI environment to make sure that it is a security gateway. So 2 things I want to mention. First of all, shift left is a term you should search for to read more about it. And shift left means as early as possible. Inside the IDE is perfect, but to make sure that everything is really scanned inside the CI environment makes sense as well. So inside the IDE and inside the CI/CD environment. What we learned from the Solarwinds hack? First of all, we learned that we should be aware of binaries we are consuming. Think about the log4j stuff. So it's just a dependency, it's a logging API, but it has a CVS as of 10, and it's really able to compromise the whole system. And same with Solarwinds hack. So make sure that you're not consuming compromised binaries. So that's one thing what we learned. We have to protect against consuming compromised binaries. But on the other side, what we learned is that with the Solarwinds hack and attacks against the supply chain, we have to make sure that we are not distributing binaries. And this is by far even worse. So not only using compromised binaries so you have damage on your side? No. If you are the multiplier of them, then you're losing a lot of credibility on the customer side. So consuming binaries as well as distributing binaries is what we learned from the Solarwinds hack. So we have to protect against two sides. Based on the Solarwinds hack, there was this executive order of cybersecurity, and this was given by Mr. Biden, the US president. And to say the truth, in the beginning, what is an executive order? I have no clue about it. It's something from the US side, and why should I take care about an executive order that's given by a US president? I'm living in Europe, I'm working for some other companies, or I have customers in my area or whatever. So why should we think about the executive order and what was part of this executive order that was given based on the Solarwinds hack? What is an executive order? So thinking about an executive order is that the US president is something like the CEO of a company. He is a president of the United States and his company is more or less a government. And an executive order can be given by the US president only. And what can he do? So he can't change law, he can't change taxes or whatever with an executive order. But with an executive order, what he's able to do is that he's changing the way the government is working. It's like a CEO, he's able to reorganize or restructure the processes inside a company, but he's not able to change the law from the country the company is in. And the same is with the executive order. So the executive order is changing the way the government is working, and this can have a huge impact. So what's the impact of an executive order, and especially the executive order of cybersecurity that was given by Mr. Biden? So the main point is that the component or the core meaning of this executive order of cybersecurity was that every IT system that is used by the US government, created, used, or whatever, so it's somehow operating for the US government, must fulfill now the requirement of an SBOM. I will cover this in a few minutes, what an SBOM is, but having in mind that something that the US government wants to use have to fulfill a requirement, mean that all indirect companies that are involved are using this one. So the US government is spending a huge amount of money for service, and they're using Amazon, they're using Microsoft, they're using their own IT infrastructure, and so on and so on. And if now there's a requirement, it means that if Amazon wants to make money with the US government, then they have to fulfill this requirement. And if I'm providing something for Amazon, then I have to fulfill the same requirements, and so on and so on. So directly or indirectly, more or less the whole world is affected by this executive order of cybersecurity that we have to fulfill the requirement of an SBOM. What's a full impact graph and why do we need them? So a full impact graph is something that's going over the whole tech stack you have. So we are not talking about a single dedicated layer, we are talking about the whole full tech stack. And a full impact graph is that if you have vulnerabilities in all those different layers, you can connect them in a way that you can say, this vulnerability in this class is part of this jar, is part of this web archive, is part of this Docker layer, Docker image used in this Helm chart. So this is something that's called full impact graph, because you have a vulnerability in some kind of technology, but you know at what other places this vulnerability is indirectly part of. So, and if it is part of something, then it can be misused. So it makes sense to know this jar is part of this Helm chart, because this Helm chart is used for this production environment. So this is a full impact graph, and we need this because with this we can analyze all different attack vectors that are available. If you want to have the full impact graph, so what is the best place to get this full impact graph? So for this you need a place where all binaries are stored, because then you have the possibility to access all binaries in once. The next thing is you need the knowledge about all this metadata of these binaries. An example. If I have a Maven, a jar artifact, a Maven artifact, then it's good to know if this jar will have dependencies and these dependencies will have other dependencies. And this is called metadata, metadata of this binary. So I need all this information about dependencies and other metrics so that I can understand this layer fully, and then I can combine this metadata from all these different tech layers to a coherent picture. And this is something that I can analyze. This is something that I can use for detecting vulnerabilities, attack vectors, and so on. So to get this information, I need a place that can contain all the binaries, and Artifactory from JFrog is exactly one of these places, because inside Artifactory we have all these different dependency managers, and the dependency managers have the binaries as well as metadata. And to access this, we have X-ray, and X-ray is reading not only the binaries but the metadata as well, and now can start with the security scan. I mentioned that X-ray is a part that is able to scan this one, but what's X-ray? X-ray is a security scanner from JFrog. It's part of the free tier and part of the professional and enterprise environments, and we have this full DevOps environment. The core is Artifactory, where all the binaries and dependency managers are placed, and then with X-ray we are reading it, and X-ray has a concept of rules, policies, and watches, and some other stuff. So what are rules? Rules are stateless atomic definitions what should happen if you are finding something with a CVSS value between A and B. Then if you have different rules, you can combine them in a composition, and this composition is called policy. So with this you are able to map compliance documents with the policies and rules in X-ray, because then you can say every chapter is a policy, and inside every chapter, every action is a rule, and so on and so on. So it's a quite convenient way to define what should happen. A rule can do the following. It can notify someone, it can break a build, it can start a webhook, and so on and so on. With the possibility to start webhooks and our REST API, we are able to have this dynamic workflow. So there's something found, it will trigger something external. This external tool is coming, reading this data, doing something, and so on and so on. And then you can use this inside your CI environments, for example, to have dedicated build steps or whatever you want. You can be very creative. But then we have watches. So inside the web UI, you have the possibilities to see all the vulnerabilities and additional information like the CVE, the CVSS values, and all this stuff. And this is inside watches, and watches is a combination from the policies, what should happen if you find something, and the resources, what you want to scan. And then you can say inside and watch, please scan the Docker repositories and Maven repositories and whatever. So if you want to know more about this one, because this is not a product pitch here in terms of all features, then you can have one of my free webinars or workshops at JFrog. Just search at JFrog for the next upcoming webinars, and then you will see there is this DevSecOps webinar from me or some practical steps with a workshop. So just feel free to grab one of the free slots and have a detailed view on the possibilities from X-ray and Artifactory, and how you can combine this one to the IDE interface so that you have all this information straight inside your IDE. Earlier in this video, I mentioned the term SBOM because it was part of the Executive Order of Cybersecurity from Mr. Biden. And what is this SBOM? SBOM is a software bills of material. And what is part of the Executive Order is that now every system that is maintained, run, used, whatever, by the US government must fulfill this requirement of an SBOM. Means that every dedicated component must be listed that is used to create this system. And this is huge. Imagine you have some service at Amazon, and the US government want to use this service at Amazon. Now Amazon has to give the full dependency list over all dependencies that are used directly or indirectly for this service. And now you can imagine what this means. So every product, every service, everything that's used by the US government, and this is a huge amount of services because they're spending a lot of money every year, then everybody has to fulfill this SBOM, and all third-party components has to deliver this SBOM as well if they want to be part of this project, and so on and so on and so on. And this means something is happening in US and I'm in Germany, has to create an SBOM because my open source library is part of this service and I want that this is used and not removed. So, or other products and so on. So an SBOM is now the full dependency list with fingerprints and version numbers and artifact names and all this stuff. So this is an SBOM, but how to create an SBOM, and is there anything what we have already that is at least something like an SBOM, maybe more. SBOM is just a list of all dependencies, and we have already something that's able to create this complete list. So having in mind that we have this full impact graph and we have this place where we can store all binaries and we have the information about the metadata. So now we have a concept at JFrog since a long time. It's called Buildinfo. Buildinfo is not only an SBOM, Buildinfo is a superset of information. So what's a Buildinfo and how to create it? So a Buildinfo is a lot of metadata that is collected during the time I'm creating a binary. So mostly during a build in CI environment, and it will collect something like date and time and operating system, agent number, environment variables and all this stuff. And additionally, it's collecting all the dependencies that are used with coordinates. So it means artifact package number or whatever, it's part of this description of the dependency, as well as the version, the name and the fingerprint of different hash sums like MD5 and so on. So we have this already and it's stored inside Artifactory so that you can push a Buildinfo inside Artifactory. It's stored there in a dedicated repository. So you have this information, and there we are addressing the term of or this change of vulnerability. So inside a Buildinfo that's immutable, we are adding the information of the current vulnerability database, for example. So you have an actual view of all dependencies, all metadata, as well as the actual version of vulnerabilities. And this is a huge superset of this SBOM. So do you need to create an SBOM? For sure. Use Buildinfo, it's part of it. How to create a Buildinfo? Well, we have different possibilities inside the CI environment, as well as a command line tool, as well as Maven wrapper, Go wrapper, Docker, and so on and so on. So how to create a Buildinfo? The technical part, how to do it, it's more than 10 or 15 minutes to explain what you need, but I have a how-to for this, and then you can see how to create on command line for your tiny project, for your big project, for your product or whatever, the Buildinfo and how to store this inside Artifactory. If you want to try all this together, you can use a free tier. So Artifactory is part of it, X-Ray is part of it, and you can create with a free Buildinfo tool on your desktop if you want inside your IDE the Buildinfo, push it there, or just reading the JSON file or whatever you want to do with it. So are you prepared for fulfilling the requirement of this executive order of cybersecurity? Yes, you are, because you have access to free tools that will give you the possibility to create it in a minute. We had a lot of stuff and it's time to close this video. So it was a pleasure for me to see you here, and it would be really nice if you would try all this. If you want to try it, just register for my free workshops, or if you have a Java user group, a meetup group or whatever, just invite me and I can give you virtually or maybe in person, depends a little bit on the COVID stuff, but I can give these workshops inside your community. So feel free to contact me. The best way to reach me is Twitter, LinkedIn. If you want to see more stuff, connect via YouTube, and it would be a pleasure for me to see you as my new subscriber. So you're more than welcome to be part of my social network. And yeah, if you have any questions, feel free to reach me, ping me via media that is suitable for you. Don't use email. Email is a mess by me. So please use something, but no email. Otherwise, yeah, it was a pleasure to see you here. I hope you enjoyed it. Give me a thumbs up, a good vote or a star or whatever is possible here. And then I say thank you, whatever time you are watching this. Have a nice day. And the last thing I can say, stay safe and see you.